Okay, and let's take a look at problem number 5. Problem number 5 asks us to determine the values of V1, V2, and VAB. So V1's right there, V2's right there, and then we have these terminal values VAB. Okay, so I'll write VAB on the top of those. All right, so let's take a look at what's happening in this circuit. We'll start looking on the left side and we'll work our way across. So if we look at our left side, we see that we have a battery, and this battery is going to produce some current that'll come up through here, travel, and it'll hit this node, and it'll see it has two directions to go. It can either go down this way or down this way. Well, if we look at the concept that we had to where current can't travel down an open wire, so where it's open like this, the current can't make that jump. So that is not allowed. All right. Current can only travel down a wire that is complete. Okay. So with this in mind, looking at our circuit, we see that no current is going to be able to travel down this branch here. So that current will just continue on this way, and it's going to hit this node here. All right. And let's look at what its options are. It can either go this way or it can go that way. Another concept that we have is current wants to follow the path of least resistance. So current wants to follow the path of least resistance. Okay, so looking at our options here, we either can go down the right side, which has a 6 ohm resistor, or we can go down the left side, which has nothing. There's no resistance. So what the current is going to do is it'll say, okay, I'm not going to go down this way because there's resistance, where I can just go down the other side where there's no resistance and I don't have to fight it at all. So that current will just come through here, loop back around, and it makes one complete loop. So this is current I1. Okay. Let's come over to the right-hand side now. Let's take a look. So the right-hand side, we have 2 amp current source. It'll come up through here. It'll travel. It'll hit this node, and it'll see it has two options. Just as before, it can go this way, or it can go that way. And like we said before, right here, that the current can't jump down an open wire. So we'll just go ahead and remove that from the equation. So the current can't travel that way. So the current will just come travel through here, hit this point, and once again, it has two options. And then same as what we were talking about earlier, the current can either go down the left side where there's that 6 ohm resistance, or can come down the right side here where there's no resistance. So the current, once again, chooses to go travel down the path where there's no resistance, and it won't send anything that way. So it'll just continue on up through here, and that'll give us just our looping current that way. Okay, so now we have some information relating to those. Let's see what we can do with it. Okay, so we'll look at the left half first. If we were to draw it out like this, so 8, 7, this will be I1, and then this was V1 right there, plus minus, and then 15 volts. Okay, so if we want to find V1, we can do a voltage division, which would just entail us doing V1 is equal to R7 over 7 ohms over R equivalent times V of the source, which would just give us R7 ohms over R equivalent here would be R of S, times V of S, okay? And in this case, R of S is just gonna be 8 plus 7. That'll give us 15 ohms, all right? So V of 1 here is going to be equal to 7 ohms over 15 ohms times 15 volts. And this will give us 7 volts for V of 1. All right. So now that we have that information, let's go to the right-hand side and we'll repeat the process. Where this is 2 amps, this is 2 ohms, and this is V2 plus or minus. Okay, and we know that 2 amps travels throughout that circuit. So all we have to do is V is equal to IR, which is just going to be 2 amps times 2 ohms, which will give us 4 volts for V of 2. All right, but now we need to figure out what VAB is. All right, so what's important is that we know the values for V1 and V2. So what does that actually mean for V1 and V2? Well, if I was to take this point to that point, what it means to lose that 7 volts is from here to there, you're losing 7 volts. And from here to there, you're losing 4 volts. All right. And how we were saying before, how voltage along a wire is the same until it hits an element, that holds true here. But something that's very important is notice along that branch and then that branch, no current is running through it. So if no current runs through it, then no voltage can be absorbed or supplied, but it still has voltage in it. Okay, so you can't add or subtract, but it will just maintain that same value. So what does that mean? Well, that means that we found that, well, we know that down here, this will be 0 volts. That'll be 0 volts. And we see that we lost 7 volts here. So that means that our point up here has 7 volts before we enter that 7 ohm resistor. We know that down here, there's 0 volts. Down here, there's 0 volts. And before we hit this resistor, we had 4 volts because we lost it all to the 2 ohm resistor. So now what we can say is that we know that that point and that point have voltage values. So this will be 4 volts. This will be 7 volts. And since this is the same wire, V of B will be equal to 4 volts. And we know that since this is the same wire, V of A will be 7 volts. So all we need to do is take the difference. V A B is equal to V of A minus V of B. So 7 minus 4 volts will give us 3 volts for VAB.